All right, in this problem, we're asked what type of function, we're also asked why, and we see that our data is the days since January 20th of 2020, which is when COVID first hit the United States. And then we have the number of confirmed COVID cases. Now, our data does have a point that it skips here. So day 1, day 2, and we don't have data for day 3. So over here where I did the change in day, I just had us do that for day 4 onward. So I didn't have us use those first data points. We know that change in Y is where you take, go back here, where you take Y1, Y2 minus Y1. And we know that the Y ratio is where you take Y2 and divide it by Y1. And I went through and calculated those and put them all in. So what I observe from doing the change values is that they are not constant. And what I observe from doing the ratios is that they are also not constant. So even though I can do all of this work, it actually doesn't tell me anything because it's just telling me that it's not exactly linear, not exactly exponential, but I might end up using one of those anyway if they're the best fit. So I really have to go out and create the graph to know what's going on with the data. So in the calculator, I went in, I'll show you here, I went stat, I went enter to edit. When I type these years, real careful there, go 1, 2, 4, because we don't have data for day 3, and then on, and I typed in the number of confirmed COVID cases as well. So now I want to set up my window. So looking at list 1, this is my X, so I'm thinking like 0 to 12. Looking at list 2, I think I'm going to start at 0 as well because 282 is not that far from 0. And looks like I need to go up to 10,000. So going to window, 0 to 12, 0 to 10,000. And then I'm going to go to my Y equals, clear out my last formula that I had there, and make sure that I have plot 1 turned on so that I will see this data. And so I hit graph. And when I look at this data, I very clearly see a concave up curve. It starts out increasing very slowly, pretty flat at the beginning, and then it goes up from there. So I'm going to attempt a sketch. So what we had going on here was the days, 0 to 12, and our COVID cases, 0 to 10,000. And our data points started off pretty flat and then go up from there. Now, we did not have constant ratios, so that means that when we find a curve for this, it's not going to be perfectly exponential, but it is concave up. So what type of function should I use? I should use approximately exponential. And why should I use that? And it's because of the concave up shape in the data. So going out to my calculator, I'm going to find this by going to stat, and I want to go over to calculate. And this time I need to arrow down a lot further. So I am looking for an exponential, and so it's down here at number 10. So this EXP stands for exponential regression. So I hit enter. And again, you're going to have to hit enter as many times as it takes for your calculator to do something. I am going to store this. So I'm going to go bars, Y bars, function, Y1. And I'm doing that so we can look at our graph, even though that's not something that we were asked to do. So enter, calculate. And we see that it gives us the NPAT formula. And so we see the starting amount here is 169.12. And then we see our A value in NPAT, which is B in the calculator, 1.475 if we round off. So let's write this down. So find the equation. And so we have Y is equal to 169 0.12 times 1.475 to the x power, or you could put the t power for time. And then we weren't asked to do this, but I want us to go back and look at this. So in my y equals, they typed it in with all of those decimals, which is amazing. And then I'm going to hit graph. And we see that our line is a great approximation, but it's not exact anywhere. So it looks like on our second data point, really, really close. The first 3 data points that we have are really close. You see it's missing day 3 here in the data, which we had talked about. And then it's a good approximation. This one point here, which is day 1, 2, 3, 4, 5, 6, 7, 8, I believe, is off by a good bit, but then it's really close again. Days 9, 10, and 10, 11's off by a good bit again as well. So that's always the case when you do an approximation. You're going to get an estimator, not the exact values. If it had been exact, we would have found constant ratios, but we didn't find that, so it's definitely an estimate, but a much better estimate than if we had used a line for this graph. So to review, what type of function? Approximately exponential. Why? Because of the shape of our data.